generations have felt they've reached the pinnacle of technological advancement. Yet look back 100 years, and the technologies we take for granted today would seem like impossible magic. So, will there be a point where we reach an actual limit of technological progress? And if so, are we anywhere near that limit now? Half a century ago, Russian astronomer Nikolai Kardashev was asking similar questions when he came up with a way to measure technological progress, even when we have no idea exactly what it might look like. Anything we do in the future will require energy, so Kardashev's scale classifies potential civilizations, whether alien civilizations out there in the universe or our own, into 3 levels based on energy consumption. The tiny amount of energy we currently consume pales next to what we leave untapped. A Type 1 or planetary civilization can access all the energy resources of its home planet. In our case, this is the 174,000 terawatts Earth receives from the sun. We currently only harness about 15 terawatts of it, mostly by burning solar energy stored in fossil fuels. To approach becoming a Type 1 civilization, we would need to capture solar energy more directly and efficiently by covering the planet with solar panels. Based on the most optimistic models, we might get there within just 4 centuries. What would be next? Well, the Earth only gets a sliver of the sun's energy, while the rest of its 400 yottawatts is wasted in dead space. But a Type 2 or stellar civilization would make the most of its home star's energy. Instead of installing solar panels around a planet, a Type 2 civilization would install them directly orbiting its star, forming a theoretical structure called a Dyson sphere. And the third step? A Type 3 civilization would harness all the energy of its home galaxy. But we can also think of progress in the opposite way. How small can we go? To that end, British cosmologist John Barrow classified civilizations by the size of objects they control. That ranges from mechanical structures at our own scale to the building blocks of our own biology, down to unlocking atoms themselves. We've currently touched the atomic level, though our control remains limited. But we potentially could go much smaller in the future. To get a sense of the extent to which that's true, the observable universe is 26 orders of magnitude larger than a human body. That means if you zoomed out by a factor of 10, 26 times, you'd be at the scale of the universe. But to reach the minimum length scale, known as the Planck length, you would need to zoom in 35 times. As physicist Richard Feynman once said, there's plenty of room at the bottom. Instead of one or the other, it's likely that our civilization will continue to develop along both Kardashev and Barrow scales. Precision on a smaller scale lets us use energy more efficiently and unlocks new energy sources like nuclear fusion or even antimatter. And this increased energy lets us expand and build on a larger scale. A truly advanced civilization, then, would harness both stellar energy and subatomic technologies. But these predictions weren't made just for us humans. They double as a possible means of detecting intelligent life in the universe. If we find a Dyson sphere around a distant star, that's a pretty compelling sign of life. Or what if, instead of a structure that passively soaked up all of a star's energy, like a plant, an alien civilization built one that actively sucked the energy out of the star, like a hummingbird? Frighteningly enough, we've observed super-dense celestial bodies about the size of a planet that drain energy out of a much bigger star. It would be much too premature to conclude that this is evidence of life in the universe. There are also explanations for these observations that don't involve alien life forms. But that doesn't stop us from asking, what if?